We're now going to look at mixed circle theorem examples. In other words, we could be using any one of the first 6 circle theorem properties we know so far to calculate unknown angles. So if you look at the first example here, it says find the angle ADB below. Now we need to locate where this angle is. ADB means you look for triangle ADB, and it's the angle formed at D. The middle letter is D, so we're talking about this angle here. That's the angle we want. Now we're given an angle of 40 degrees, and somehow we've got to travel from 40 degrees over to D to work out what it is. The thing that hopefully will stand out straight away is that if you take AB as a chord and you draw a triangle from that chord such that it forms an angle at the centre, and you draw another triangle from the same chord such that it forms an angle at the circumference, then the angle at the circumference will be twice the angle at the centre. So if we can work out the angle at the centre, we can then work out the angle here at the circumference. Now the angle at the centre is one of 3 angles that make up the angles in this triangle. You've got a 40-degree angle. If we knew the angle at A, we could then use angles in a triangle to work out the angle at O. And we can work out the angle at A because the angle at A is formed between the radius of the circle and a tangent to the circle. So that means the angle in here is 90 degrees. So straight away, the angle there is 90 degrees, and that's because of tangent and radius. That's circle property 5. Okay, so now we know 40-degree angle and 90-degree angle. If we add those together, we get 130. If we take 130 away from 180, we're going to get 50, and that's going to be the angle at the centre. So angle at centre is going to be 50. And we just used angles in a triangle to get that. So now we can get the angle at the circumference. As I was saying earlier, if you trace over AB, which is the chord, and we draw a triangle from that chord such that it forms an angle at the centre, and then we're going to draw another triangle from the same chord such that it forms an angle at the circumference. Then the angle at the centre is twice the angle at the circumference. So that would mean that the angle at D would be 25 degrees. Again, that's because of angles at centre and circumference, ACC. So to put it all together, final answer then, ADB is equal to 25 degrees, and then we'll put all our reasons in brackets starting in chronological order. So we worked out this angle first as being 90 degrees because of tangent and radius. We then worked out the angle at the centre using angles in a triangle. And then finally we worked out the angle that we were looking for by using angles at the centre and the circumference, ACC. Okay. Okay, our second example then. So we're given an angle here outside the circle, which is 80 degrees, and we want to work out the angles A, B, and D. So first of all, let's start from the 80 degrees. we have a point outside the circle and we've drawn a tangent from that point such that it touches the circle at this point of contact. We've drawn another tangent from the same point outside the circle such that it touches the circle at another point of contact. Now, circle theorem number 6 tells us that when you draw two tangents from the same point outside a circle, the distance from the point outside the circle to each point on the circumference is the same. So I'm going to put little ticks down indicating that this distance and this distance are exactly the same. So if we take a look at this triangle in here, it must be isosceles if two of the sides are the same. So if these two sides are the same, then these two angles have to be the same. Now, in order to get these two angles, what we can do is take 80 from 180 degrees, and that's going to leave us with 100 degrees. So these two angles must add up to 100. If we divide 100 by 2, because these two angles are the same, we're going to get 50. So that angle is 50. And this angle is 50. And again, that was because of circle theorem property 6, two tangents, and the fact that we have a triangle, an isosceles triangle. So we were using two tangents, an isosceles triangle, and obviously angles in a triangle. So we've worked out A is 50 degrees. So straight away we can write down A equals 50 degrees, and that's because of an isosceles triangle. Sorry, I should say two tangents, an isosceles triangle, and angles in a triangle. Now, can we work out B? Well, we can, because from the center of the circle to this point of contact is the radius, and then from this point outside the circle to this point of contact is going to be the tangent, and you know that radius and tangent meet at 90 degrees. So we know straight away that this angle in here, B and A combined, is going to be 90 degrees. So if B and A add up to 90 degrees, then that means B must be equal to 40 degrees, because we subtract 50 degrees from 90, we get 40. So we used the tangent and radius property there to work out B. Okay. Now, if we can work out C, then we've got a good chance of getting D. So to get C, we now consider the triangle O to this point of contact, and then from this point of contact to the other point of contact. Now this triangle here is also isosceles, because from O to the point of contact here, that's a radius, and from O to this point of contact here is also a radius. So these two sides are the same. So I'm going to put little ticks in those, different ones than these. So they've got to be the same. Now if they're the same, that means angle B here has to be exactly the same as the angle over here. And we know that angle B is 40 degrees. So if angle B is 40 degrees, then this starred angle up here, it has to be 40 degrees. So these two angles are 40 degrees, add them together and get 80. Then subtract 80 from 180 degrees, and that's going to give you angle C, which is going to be 100. So angle C is equal to 100 degrees. And the reason for that is because we used the fact that we had another isosceles triangle here, and therefore angles in a triangle allowed us to get C. So isosceles triangle and angles in a triangle. Okay, to get D then, the last bit is if we take the chord to be the line running between the 2 points of contact here, so we take that as a chord, and we draw a triangle from that chord such that it forms an angle at the center, like that. And then we draw another triangle from the same chord such that it forms an angle at the circumference, like that. Then the angle formed at the center is twice the angle formed at the circumference, and we know that the angle formed at the center is 100, so that means the angle formed at the circumference must be 50. So D must be 50 degrees, and that's because of angles at center and circumference, and that was using the red chord. And that's our answer for the second example. So as I say, it's important in these questions that you give reasons as to how you worked out each angle, okay, in the question. And there's no problem with, writing over the diagram. If it's possible, try to print out the question sheet if you can, and then obviously write the angles down as you work them out as you move through the question. If you can't print out the questions, then it wouldn't do any harm to draw a sketch of the diagram, a neat sketch of the diagram, and then obviously work through the diagram, putting angles on it as you proceed.